Let's look at quicksort. So quicksort is another divide and conquer algorithm, and it is generally faster than merge sort for practical purposes because it does not require extra space for merging. So as we've already seen with merge sort, we need an extra space for merging this the subarrays basically. But now, however, the one problem with the quicksort algorithm is that in the worst case performance, it can have a time complexity of n squared, and that does happen in some situations. And some of the situations could be probably maybe choosing an depending on even how the array is, and we're going to see that in a moment. But first, let's see how quicksort works. So can start here. So how it works how it works. The first step that we take when we're dealing with quicksort is we need to choose a pivot element from the list. So we're going to choose a pivot element, and let's have such a thing here. So let's say this is our list, and I'll just move it down here, have it in red. So let's say this is our list and it has multiple elements. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So maybe it has about 10 elements, right? So the first thing that we do is we choose a pivot element, and after choosing the pivot element, we go ahead and partition the list into two sublists, one containing elements that are smaller than the pivot and another one containing elements that are greater than the pivot. So let's say we choose this element here. So whatever element is at this position, let this be our pivot, right? Then now after doing that, we're going to have two different basically sublists. One is going to have elements that are smaller than the pivot element, and another one is going to have elements that are greater than the pivot element. And what that basically shows you is that you already have one element that is at the correct position where it should be in a sorted list. So moving forward, the next step that we've basically said is should be a T. We are going to partition the list into two sublists. The list into two sublists into two sublists, and I'm not going to write everything else, but we've already seen after we submit how we do that is we choose elements that are greater than the pivot and less than the pivot, and all of them are going to be in different sublists. So after doing that, the next step we're going to do is we're going to recursively now apply the same process to the sublist. So we're going to just say recursively apply. Okay, I'm getting a bit okay. So recursively apply the same process to the sublists. And once we do that, after we are done, we are going to combine the sorted sublists and the pivot to form the final list. So we're just going to say here combine. We're going to combine to form final sorted list. Yeah. So again, we choose the pivot. Then we go ahead and have elements that are less than the pivot and elements that are greater than the pivot, both of them different subarrays or sublists. And then we go ahead and recursively do the same for each of them. So if let's say we look at the ones that are less than, we also go ahead and choose a pivot. So choose a pivot for those ones, and then also check which one is smaller and which one is greater, and we're going to repeat that process until every element is at the right position where it should be. So, and we can do this. Let's try and maybe consider a more practical example for this. Okay, this P should be here. And okay, let me just get rid of this too. So let's consider a more practical example where we can apply such a thing. And that is going to be now, let's have an array, a list here. So let's have a list, and this list can have a number of elements. So you can have even the same as we had before, but let's say randomly have 9, maybe 7, maybe 5, 11, 12. Can have a 2, 14, a 3, let's have a 10 maybe, and lastly a 6. So if we have a list like this one and we want to sort this using quick sort, the first thing that we've said we need to do is we need to choose a pivot, right? So if we go ahead and choose an element, let's say 10 as our pivot, right? If we choose 10 as our pivot, then we're going to go ahead and partition the list with elements that are less than 10 are going to be on this side, and elements greater than 10 will be on this side, right? So elements that are less than 10, how this is going to look like in the aftermath of doing that. Elements less than 10, we're going to have, let's say 9, then we have 7, we're going to have 5, we're going to have 2, and 3, and is there another element here? We're going to have 6 as well. Then we're also going to have a second array here, and this one is going to be elements greater than 10. So elements that are greater than 10, we have 11, we have 12, and we have 14. And then we're going to go ahead and apply that same process. So let's say we start with the left sub array here. We also pick a pivot, right? So if we pick a 5 as the pivot, we repeat that process until we have the entire list basically sorted. So how we can apply this in code, it's actually quite easy on how we can do this. So the first thing we need to do, of course, let's have a function, and we're going to call this function quick sort. It takes in our array that we want to sort, and what we're going to do is first of all check the size of the array. So if the length of the array is less than or equal to 1, if that is the case, we're going to go ahead and return that array for obvious reasons here. So we're going to return array. But if it has more than one element, then we're going to go ahead and first of all pick our pivot. So we can store it in a variable called pivot. And how we pick our pivot, we're going to check the array. Then it's going to be just length of the array should be like that. So length of the array. Then we use a flow operator on this one as well. So flow operator and 2, like that. So like that, we've chosen our pivot. Again, most of the time you'll find that we're going to choose a pivot as to be the element that is at the middle. So the middle element is most of the time you find choosing as the pivot. Then from there, now we need to get the left sub array, the right sub array, and the middle element. So we can just quickly do this. So can have the left sub array. How we're going to get this is we're first of all going to have a for loop and check if basically going to check or rather iterate through the array. So we're going to maybe just say for x in the array, then we're going to check if x is less than the pivot, then we basically return x, and that x is going to be that's going to be the left sub array. Then we get the middle, do a similar thing for this. So we're going to just return x for x in array if x is the pivot, like that. Then we do the same for the right, and we're also going to return x for x in array if x is greater than the pivot. And with that, what we're going to do, see an error here, or it should be a single O. Yeah, and once you're done with that, we're basically now going to return our sorted array. So we're going to return. So again, we just do get the left here. So the left is going to be sorted recursively. then we're going to just add the middle here, and finally we're going to also apply the same process for the right subarray, the right sublist. And with that, we're going to have a sorted array. Just to confirm this, we're going to print the output, and we call this quick sort, uh, and we're going to give it an array. Let's go ahead and give it this one. This one is not sorted, so let's give it as the argument. Save that and run it again. So should be Python 3 quicksort. And as you can see here, our array looks sorted: 2, 3, 5, 6, 7, 9, 10, 11, 12, 14. Yeah, our array is sorted by quicksort. And that is basically how you implement quicksort. And as I mentioned at the beginning, in most cases, quicksort is going to have a time complexity of, so in most cases, it will have a time complexity of O of n log n, of n log n, and this is again because we're basically reducing the input, or rather the number of inputs that we're processing at every iteration, basically, that at every time. So it's going to have a time complexity of this in most cases, and in practice it's highly efficient when you do this, but sometimes it can degrade into an O of n squared. So in worst case, it can get to O of n squared. And if this could happen now if you choose the pivot, you choose the pivot poorly. So let's say if you're always picking the first element in an array that is nearly sorted as your pivot, then that you're going to have a time complexity of n squared. But that's basically it about quicksort. Thank you for watching up to this point, and I'll see you in the next one. We're going to be looking at heapsort.